Welcome. I hope you're doing well. Thanks for checking out this for loop iteration challenge. I'm sure you've already messed around with this code yourself quite a bit, and now you're just kind of checking answers. So let's go ahead and jump right in. So the first challenge was change the value of the timer variable, and just kind of see what happens. Okay, so let's go ahead and go to our code, and let's find the timer variable. Alright, there's the timer variable. Right now it's set at 100 milliseconds. So what I'm going to do is I'm going to just cut it right in half. And what I think is going to happen when I cut it in half is that the timing of the LEDs is going to cut in half. So that space between each light will cut in half, and it's going to go back and forth quicker. That's my hypothesis there. So I'm going to go ahead and verify and upload the code, and then take a look at the Arduino board, and in fact it is definitely moving quicker, and I'd say probably twice as fast. So that's pretty straightforward, easy enough. So now I'm going to go ahead, I'm going to set it down to 2. That's pretty low. We're just trying to check how low can we go kind of thing. I'm going to verify and upload this, and now when I take a look, you can hardly even tell that it's going back and forth. In fact, I would argue that you really can't tell that it's going back and forth. It's just doing it so fast they look like they're all on. So the takeaway here, I guess there's kind of a couple takeaways. I generally like to try the lower and upper limits of a variable when I'm setting up a program, just to see what the program, how the circuit's going to handle that range. Because what I might want to do is constrain the range of a variable. And we'll talk about constraining variables later, but so that might be something I'd think look into. But the other thing, and this is a little more general, is when you're setting up your programs, this top part, this block of code where we initialize and declare variables, try to think about it as like the Starship Enterprise in the bridge. There's the one guy with the cool glasses, and he sits there and he presses those buttons. Well, I think of these variables, the inputs, where you can change its value, as these different buttons, and you can control all this cool stuff from this console up top. So when you're building your program, try to stay away from hard coding numbers, but instead using variables, putting them up there in that block of code where you initialize and declare, so that you can change things so much easier by just the change of one keystroke. Because I could have, instead of having a timer variable, the programmer could have gone through and manually typed in 100 or 10 or 50 or whatever in the delay function, but they didn't. They wrote a variable, and it made their lives easier, made my life easier, and it will make your life easier. So make people's lives easier. Alright, so let's go ahead and jump into the second challenge. Add 2 LEDs at pin 8 and 9 and adjust the for loops accordingly. Okay, well, check out the schematic. So this is easy. The schematic's easy enough. All we're doing is following suit. So we're going to put resistors in 8 and 9, 220 ohm resistors, accompanying LEDs in 8 and 9. So we're just kind of continuing that row. But now the real question comes, what do we have to do on the code? So let's go ahead and take a look at the code. So the first thing I'm going to do is set back the nominal value for timer, which was 100. And now I'm going to come down, I have to ask myself, well, what do I have to do to my for loops? Okay, so what I would argue is all I have to do is change the threshold, this condition on the this pin value, from 8 to 10. So now this pin less than 10. So what that is going to do in this for loop is the for loop is going to continue until this pin is 9. Because if this pin is 9, so pin mode, we'd set the mode of pin 9 where our new additional LED is set. We'd set it as an output. And we'd come down here, we'd add 1 to pin 9 because we'd do our incrementation. That would make it 10. And then the for loop would quit because 10 is not less than 10. Okay, clear enough. So that's that for loop. You know what I'm going to do? I'm going to upload and verify that just to see if anything goes wrong. I altered one thing. I want to verify Does anything I do to my sketch break it? Okay, no, it didn't break it. It compiled just fine. Okay, so now I'm going to move on to my next for loop. Whoa, it's the exact same thing, but this time we're writing high voltage and low voltage. So what would I have to do? Well, I think I'm just going to do the same thing. I'm going to change that from 8 to 10. And you know what I'm going to do? I'm going to upload it. I'm going to verify and upload. That's what I'm doing. I'm making sure that that change I just made didn't break the program. Now I could make all those changes and then hit verify, but then I wouldn't know which change made the mistake. So every time I change the code, I like to verify. Okay, so that was that. Now I'm going to come down to this last for loop. Alright, this last for loop. Oh, this one's kind of funky. Well, I think here, since we go in reverse, I think here I just have to change this from 7 to 9. So now I'm going to start at pin 9. I'm going to blink pin 9. Then I will subtract 1, blink pin 8, subtract 1, blink pin 7, all the way down until I blink pin 2, at which point, so digital write this pin 2, we'd be turning it off. So then we would we would subtract 1, doing our decrement from 2. That would bring it down to 1. And then is 1 greater than or equal to 2? 1 is definitely not greater than or equal to 2, so that for loop would stop. Alright, so I think I've made all the changes in the code for this to work right. So I'm going to go ahead and verify and upload. And it's working. Man, that happens so infrequently. Okay, now we might stop there, but I would be a hypocrite, because what did I just do? I went through and did a bunch of hard coding. And just at the beginning I said, hey, you shouldn't hard code. So let's go ahead, let's build our Starship Enterprise Council. So what I'm going to do is I'm going to make a new variable, and I'm going to make it an integer, and I am going to call it high pin. No, I don't like that. That's not very descriptive. I'll put, let's call it last pin, and I'm going to let it equal 9, and then I will say this is the last LED attached. That kind of makes sense. I think it makes sense enough. And then I'm going to make another one, and I'm going to call it first, you know what? I don't even like pin. Let's make this LED. Is that a little more descriptive? Last LED, first LED. And I'm going to say the first LED is 2. Okay, and then I'm going to change this comment because I'm going to try to just get a little more descriptive. I'll say this is we'll call it the pin number. The pin number the last LED is attached to, and then I'm just going to copy that comment, paste it here, and then I will say the pin number the first LED is attached to. Okay, so now I've got 2 more variables that I've added. You know what I'm going to do? I'm going to verify this code because I just made changes. I want to make sure that maybe I missed a semicolon, or maybe I had a number that was outside of the bounds of integer. I want to check if I'm getting any errors. So when I do that, I'm checking down here to see if I'm getting any errors. Okay, I didn't get any errors. So where do I need to put these? Let's look at the first for loop. Well, in the first for loop, that upper value is actually 10. So how could we make this work? So what I propose is that we say we invoke our new variable, last LED, and then we say +1. Okay, and then I'm going to put it in a parenthesis so we know that operation gets done. So I'm going to say last LED +1. So this pin is less than the last LED +1. So that, what would that be? That would be 10. And then it would change for whatever last LED we use. So if we go all the way up to 13, if we use the 13th pin, then this value here would be 14, and once we got to 13, it would jump out of the for loop. I hope that kind of makes sense. I think you're following what I'm saying. So last LED plus 1. Okay, easy enough. And what I'm going to do is verify that code. Alright, and then what I'm going to do is come down to the next one, and you know what? I think I'm going to use the exact same statement because it's the exact same condition here. So I'm just going to go ahead and paste that in there, and I will verify it. Any issues? Okay, no issues. And then finally, okay, let's see. Finally, so this pin equals, you know what? I think here I can just let this pin equal last LED straight up. Okay, so this pin equals last LED, so that's where it's going to start, and then it's going to stop. Well, that's 2. Why don't I just make this first LED? Okay, so that's pretty easy, sort of. What do you think? I'm going to go ahead and verify it, and then I'm going to upload it. So now we've got all 8 LEDs going left and right. That's pretty cool. Now, we went through all that effort to put these variables in. Let's go ahead and let's do something interesting with it. What if we constrain the variables with our control console up here? So what if we make this 7 and no, you know what? Let's make this 5. No, let's make it 6. Okay, and let's verify and upload that, and then let's see what happens. So now you can see we're going from left to right, but we stop at 6 when we come back. So now just with that one change of one number, I was able to adjust the number of rows. So that's kind of neat. Okay, so now what if I change this? Okay, I'm going to change this back to 9, and then I'm going to change this to 4. Now, I'm already realizing what I failed to do was change the first LED number to actually put the variable in the first 2 for loops. Because if you come down to the first for loop, see this pin, we've set it equal to 2. Well, if I change first LED to 4, that's not going to adjust this. So what do I need to do first? I need to change this to first LED. Alright, and then I'm going to go ahead and verify that before I move on. Okay, no issues, and I'm going to go ahead and copy that name, and I'm going to come down to my second for loop, and I'm going to change that to this pin equals first LED. Then I'm going to come down to my last for loop, and I already noticed on the end one I did it right, so I had last LED and first LED. Okay, so let's go ahead and upload this, and now let's see what happens. So now it starts at the third LED and it goes to the last LED. So the third LED is actually at pin 4. So that's just a little confusing there because the number of the LED doesn't necessarily match up with the pin number. So that can be a little confusing, but if we keep in perspective, we know what we're doing. So now let's constrain it even more. Let's make this last LED 8 and the first LED pin 4. Oh, it was already 4. Let's make it 3 and upload that. Alright, so you can see there is a little bit of power in putting these variables up here. It did take us a little time to make the variables. Okay, yeah, we had to think through it a couple times, had to make a couple changes. But once you have it in place, now it's so much easier to change how your program works, and it'll be easier for other people who use your code. And generally speaking, it'll make your life easier. And then what it does is it adds more power. Now you can change things more quickly. Alright, well, hey, that is pretty much this tutorial challenge. I hope you learned a lot in doing the challenge on your own, and I hope maybe you learned something in doing it with me. Alright, hey, take it easy and have an awesome day. Bye.